Yesterday, we started our discussion here on pedigrees. We kind of went through it pretty fast on doing question number 1. I'm going to review just a little bit because there's a couple of things that I wanted to just talk about that I think I missed. Sometimes we'll see these where we'll have something like Roman numeral 1, 2, and 3 over the sides like this. What that means is just the Roman numeral 1 would be a first generation. Roman numeral number 2 would be the second. Roman numeral 3 would be the third generation. So if you look, numbers 1 and 2, we said a square is a male, correct? A circle is a female. So right here, 1 and 2 are mom and dad of how many kids? How many kids do 1 and 2 have? They have 4 kids. Numbers 5 through 8, right? Of those 4 kids, how many are boys? 2 boys, 2 girls. Now, I don't think I said this, but as I'm looking left to right, that goes oldest to youngest. So their oldest kid is number 5, which is a male, correct? Their youngest kid is number 8, which is a female. So in order, they went boy, girl with their kids. Now, looking at this, their youngest kid, 1 and 2's youngest kid, number 8, married 3 and 4's oldest kid, right? How many kids did 3 and 4 have? 4 kids. Okay. How many boys? How many girls? How many boys did 3 and 4 have? 2. How many girls? 2. Okay. So 8 and 9 then had kids. So 8 and 9 had 4 kids themselves. And of those 4 kids, 2 were boys and 2 were girls. Now, what we're doing here is we are tracking eye color. Okay? Now, let me ask you this. How is 15 related to 6? How is 15 related to 6? What do you think? Dylan, what do you think? 6 is 15's aunt, right? So 15 would be 6's nephew. Okay. How is 15 related to 3? Maddie? 3 is 15's grandpa. Let me ask you this. Is it a maternal grandpa or a paternal grandpa? You know what that means? Maternal or paternal? Maternal is? Okay. Maternal and paternal. Maternal would be mother. Paternal would be father. Okay, so 15, okay, 3 is 15's grandpa, right? Grandpa on his mom's side or his dad's? His dad's, right? So that would be his paternal grandpa. Okay, who would be his maternal grandpa? Number 1, right? So we see how we're reading these? How is number 10 related to 2? How is 10 related to 2? I would have to say Probably the best answer to this. Okay, I see where you're going at with that. Everybody here said daughter-in-law. Okay. Really, they're not related, 10 and 2. 2's daughter-in-law would be married to 5, right? 2's daughter-in-law would be married to 5. So really, all 2 and 10 have is, 2's daughter married 10's brother. So 2's son-in-law's sister, I guess you would say. All right? Now that we did that review, okay, isn't it kind of, stop and think, because I've seen in the paper, okay, I've seen in the paper a few times recently. I think it happened with Mr. Ben, actually. I saw it in the paper twice, because he had it on both sides, that they had a 5-generation picture, okay, a 5-generation picture. So, like, let's say Mr. Ben's son had a kid. So Mr. Ben's dad is still living, and so is Mr. Ben's grandma or grandpa, one of them. So that's a long way going there. That's a lot of years happening over those 5 generations. Now, let's get back to this. The question was, label the genotype for each of the individuals below its symbol on the pedigree chart. Note that eye color is not a sex-linked trait. So do we need to worry about X's and Y's? Okay, it's not located on the X, so we don't have to worry about this. Who can tell me where they would start? Where would you start? Brandon? With the shaded ones. Because why? Blue. Shaded ones are blue. They are recessive. Let's put one more word in there. They are what? Recessive. Homozygous recessive, right? Blue eyes, because it says right here, brown eyes are dominant over blue eyes. So, I know that each one of these shaded squares or shaded circles have blue eyes, right? I know every one of those have blue eyes. Now, where do you want to go from here? Does it matter? Okay, could we start at either side? Could we start down at the bottom? Okay, let's see if we can do this a little bit backwards. Okay, if I'm looking here at 13 and 16, right? 13 and 16, I know 8 and 9, don't I? I know 8 and 9, right? How do I know 8 and 9? Jonathan? Both 13 and 16 are recessive. So what are you going to say 8 and 9 are, Jonathan? Capital B, lowercase b. And we call that what? Heterozygous. Because neither one of them have blue eyes, do they? But they have produced kids with blue eyes. So they have to be a carrier of that blue eye gene, right? Okay. Now, do we know, does that help us with 14 and 15? They have to be dominant. Good. They have to be dominant, so we can put big B's there. Do we know the other one? We don't know. Could it be little b? Yeah. Could it be big B? Yeah. So we're going to just end up putting, like I said, I like to put that little dash there. Okay, some people put question marks there. Some people put question marks there. Okay, where do you want to roll next? Sydney, where do you want to roll next? Just pick, it doesn't matter. Where you want to go? All right, we're going to go to 9, 10, 11, 12, right in that area, okay? Now, I look there, I see 9, 10, 11, 12. What gives us our biggest hint? Okay, what's our biggest hint of 9 through 12? Lewis? 10 has blue eyes, right? So what does that tell you? Why is that a good hint? Why is that a good hint, Linda? That 10 has blue eyes. What's it tell you? I can't hear you. That number 3 is, I think you're right, just say it a little louder. Number 3 is heterozygous. Good. That tells us that this dad right here has to be a carrier, right? Now, what about 11 and 12? Let's talk about what we know. Olivia, what do you know about 11 and 12? They have brown eyes, so they got to be what? They have to have big B's, right? Do we know anything else about them? Do we know anything else, Dylan? Why do they got to be little B's? Okay. 10, mother. Who's their mother, Miguel? Who's their mother? Number 4. Can mom give them anything but a little B? No. So mom's got to give them a little B. Where'd they get the big B from? Had to be from dad, right? So we got the bulk of this guy figured out. Let's go back over now. Let's look at, I guess the only ones we have left are 2, 5, 6, and 7, right? 2, 5, 6, and 7. What do we know about them? Brandon? They're going to be heterozygous, big B. Right? You're right. You're right. They're going to be heterozygous, big B, little b. How did you know that, Brandon? Dad can only give a little b, right? Now, we've got everything figured out here except for number 2, which is the mom of 5 through 8. Okay? Do we know anything about her? Kayla, what do you know about number 2 for sure? Has a big B. What goes with that big B? Is she heterozygous or is she homozygous? We don't know, do we? We don't know. There's nothing on this. 5 through 8 doesn't tell us that she's a little b. Could she be a little b? Could be. But could she be a big B too? Yeah. So this doesn't help us with number 2. Okay? We all right with that one? Let's flip her over to 37 of your interactive notebook. Get into a different one now, because what's different about this one? Go ahead and read it. What's different about this one? It is, Fletcher, it is sex-linked. So that tells us that I've got to keep track of what? X's and Y's, right? X's and Y's. So it says, list the possible genotypes of the following hemophilia pedigree chart below. Remember, hemophilia is a sex-linked trait that is caused by a recessive allele. Therefore, you must denote the individual sex chromosomes as well as the hemophilia allele. I know we've dealt with hemophilia before. Do you know what it is? Your blood doesn't clot, okay? Your blood doesn't clot. One of my best friends in high school, her little brother was a hemophiliac. She had to be trained even when we were little. Like when she was 12, 13 years old, she got trained on how to give her brother shots so that his blood would clot. Okay? I thought that was the neatest thing in the world, that she could give her brother a shot. But, okay, let's go back and let's look at this. Okay, here we go. Excuse me. We're going to use X's and Y's. You know, could we go through and just label X, Y as in boy and girl to start with? We could do that. Let's do that. Okay? Let's do that. A box is an X, Y, right? I'm going to leave space between them. A circle is what? An XX. So I'm just going to go through and put my X's and Y's in. My X's and my Y's. I mean, it's pretty easy to tell whether it's a box or a circle, right? It's not that tough. I'm pretty good at shapes, can't you tell? Boxes and circles. I don't think I've missed one yet. Now watch me miss one here, dang it. Keep it going, man. How'd I do? Am I okay thus far, Jamie? All right. I've got all my X's and Y's in there. Now, what do I have to put with these? If it's a big N or a little n, right? The big N signals that that is normal. The little m means hemophilia. Now, just because you have a little n doesn't mean you have hemophilia. What if you're a guy? Then you have it, right? Okay, so where are we going to start? Okay, where are we going to start? What do you think? He says go ahead and start by marking the hemophilias. Okay, that's what John says. I'll agree with Jonathan here. I'll agree. Now, I'm going to mark all my hemophilias with little n's, and they're going to be red. So I see right here is a little n, right? Right here is a little n. Now, notice, did I put any little n on a Y? Because I saw quizzes that we took where we were putting, actually it wasn't, it was a half sheet. I saw some people putting letters on Y's. Do we do that with these X-linked traits? Okay, we think of sex-linked, sex X, right? Sex X. Sex X. We don't need to put them on Y's, so don't be doing it. Here's another little n. Here's another little n, right? Do I have all of my hemophiliacs labeled? Okay. Now, I need to go back and look and say, okay, what does this tell me? What does this tell me? Does it tell me anything? Absolutely does. Anybody? Fletcher, where you want to start? Number 3 is heterozygous. Would you agree with Fletcher on that? How do you know that, Fletcher? He's not shaded. My bad. She's not shaded. She's not shaded, so she's got to be a capital N. But number 9 down here, what did he get from his dad? What did he get from his dad? A Y, right? So where did he get that little n from? His mom. So his mom's got to be what we call a carrier. She is a carrier. Now, does this help us do 10 and 11? 11 should be easy, right? Why should 11 be easy? What, Linda? It's a capital N. Let me ask you this. Can I go through and look at any box that is not shaded and put a capital N? I can do that, right? Well, let's do that. Here's a box not shaded. Here's a box not shaded. Okay? So I got those. Okay? Let's go back to 10 now. Okay? Let's go back to 10. Do we know 10? What do you think, Olivia? Do we know 10? Okay? We know it's a big N, right? We do know it's a big N. Let me ask you this, Olivia. Who gave that X, mom or dad? Who gave that big N? Yeah, she just said, oh, uh-oh. The light bulb just went off, didn't it? She said, it's what? Go ahead. It's big N, little n. Okay, why is that X a little n? The dad didn't have a big N. So dad had to give her that X little n, right? Mom had to give her the X big N. Okay? Where we want to branch off now, Brandon? Where you want to branch? We got that side of the family done. Where you want to go? I guess number 2. All right. Huh? Number 2. What can you tell me about number 2? It's got to be a big N on that first X, right? Because she does not have hemophilia, does she? Can we be sure that that's a little n? Number 5 is a female with hemophilia. Now, is it very common to have females with hemophilia? No. Why not? Why is it not very common, Jamie? Dad has to have hemophilia, and mom has to at least be a carrier. Could mom have it too? Yeah. Okay. But at least has to be a carrier. So we got 2. What about 7? What about 7? We know what? We know that the front X is a big N because it's not a hemophiliac. What else? What else, Maddie? A little n. How do you know a little n? The dad can't give anything but X little n to his daughter, right? Okay. Now, let's look at this here. Let's look here again. 12. Let's go to 12. I've got a mom that's a carrier, a dad that does not have it. So what can you tell me about number 12? What can you tell me? We know something, don't we? Dylan, what do you know? Number 12. Has a big N because she is not a hemophiliac, right? Now, where'd she get that big N? Could have been from either one, right? Okay. Does Dad have to give her a big N? Yeah, he has to give her a big N or a Y, right? Did Dad give her a Y? No, so he had to give her a big N. What about the second X? We don't know, do we? We don't know. It could be big N, it could be a little n. Okay? Would that be the same for 14 then? That'd be the same for 14, I would agree. Because we don't really know, do we? We don't really know. Okay. Now, number 4. Number 4, I said we would work these first ones. Okay. Number 4 is a pedigree of color blindness. In humans, color blindness is caused by a recessive sex-linked allele. On the diagram, label the genotypes of individuals 1 through 16. Okay? So what I want you to do is I want you to go through, I'll give you a little bit of time to do this. You go through and work them, and then I'm going to fill them in. Okay? You go through and work it, and then we'll check it. I'll fill them in. Okay. I'm just going to use N's again here for normal and colorblind. So capital N is going to be normal. Lowercase n is going to be colorblind. I'm going to go through once again and start off labeling my colorblinds because I know that my colorblinds are little n's. There's a colorblind female, colorblind male, colorblind male, colorblind male. Here's a colorblind female, colorblind male, colorblind male. Now, I'm just going to start off at the top to see how I can do. Okay? Start up at the top, see how I can do. And I look. I know that Dad right here has normal vision. So I'm going to go through. And I'm going to put a capital N with all my squares that are not shaded because I know all of them, right? So I'm just writing down what I know. If I look, do I know what number 6 and number 8 are? Obviously, they are both females because they're circles. Obviously, they are not colorblind. So their front X has to be a capital N. What about their second X? Has to be what? Has to be lowercase n. Why? Their mother is colorblind. She can only give lowercase n's. Okay, let's move to the other side of the family. Okay, the other grandparents of this to say. I know 3. Let's look at 4. Does 4 tell us anything? Okay. We know that number 4 is not colorblind, right? So we know an N. What about that second X? What about that second X, Fletcher? It's got to be a little ny. The dad gives the y, the mom gives the x. Look at 9. Mom's got to give that little n, right? Because dad gave that x. Okay. What about 10? We know the front x, right? What about 12? We know the front x, right? Do we know the back x? Where'd they get that capital N from? What number? They got that capital N from number 4, right? What's dad gonna give them then? Little n. Dad can either give a little n or a y, and obviously they're girls. They didn't get y's. Okay? Now all we have left is what? 14. Do we know 14? Yeah, we do, don't we? What is it? She. I almost said, what is it? It's not an it, it's a she. What is she? Capital N, lowercase n. She's got to get that lowercase n from her dad, who is colorblind. What number? 9, right? Think you can give me a thumbs up with these pedigrees? Let me see them. We good? Okay.